We are fortunate, our last couple speakers actually come to us from our neighboring state, University of Nebraska. We tend to use a lot of data. You know, we share back and forth on the data that we do. Kansas, Nebraska, Colorado, Missouri. So we all share. So we were glad that they were able to come down and share with us in this weed management series. Their topic is going to be on some research update and application technology. Okay, we have Dr. Randy Lloyd. He is the technology research coordinator, and you can tell more information about where you're located. And I'm going to have Randy introduce his colleague. Yeah. Okay, all right, I'll turn it over to you guys.
Thank you. Well, do I need to stand here?
You're good right there.
Okay.
Yep.
Thanks for having us down. I know you probably didn't have any choice, but we appreciate the opportunity to come down and sort of visit with you on what we've got going on in North Platte. So we're located at the West Central Research Extension and Education Center in North Platte. I have been there all of about 3 months, so I'm a grizzled veteran of the facility. Actually, I started my career in the ag chem side of things. Somebody mentioned a residual product that ruined a crop earlier. Who said that? Did somebody say something about that? So I worked for AMSI back in the late 80s and the 90s in Kansas. I was located in Ottawa, so lots of Pursuit, Scepter, Prowl, those type products. And guys, if you remember Pursuit when it came out, really good product, but we started dealing with weed resistance probably 2-3 years into its lifespan. And the weed of concern at that point was water hemp. And then since then, resistance has simply exploded. Certainly with the advent of Roundup Ready soybeans, we all sort of focused on the easy way to do it, which was very, very effective and frankly, very, very cost effective. And now we're kind of paying the price for that to some extent. So, I mean, I would agree with the earlier speakers. Anything we can do to mix those modes of action up and to make these products last just a little bit longer is going to be helpful. We're running out of bullets in the gun, right? We simply don't have anything new coming. I believe some of the companies are starting to ramp up their discovery systems again. So good news on that side. Bad news is we're 10 years out probably. So it's gonna take them a while. So now that I've brightened your day with that uplifting information. So what we are focused on, in part at least at the experiment station, is we're looking at not only how to control weeds, as in what herbicides to use, but how can we take those herbicides and use them as effective as we possibly can. So we're taking obviously stuff that's already labeled, but we're seeing through application technologies and through fine-tuning nozzle selection, things like that, can we actually take a product that may be good on a specific weed and maybe take that to the next level and at least again keep it viable. So that's kind of what we're going to talk about. I'm going to sort of introduce this and then Jeff will take over. We have come a long way, so that's not when I started. That was a little bit before me. So I'm not going to make any eye contact with anybody in here to see if that is you in the back of that rig. So I'm not gonna look. But yeah, we have come a long way. So what is this? This is completely off subject, by the way, but this is one of my, kind of irks me. This is an air blast sprayer, right? So what do you think they spray out of that?
Spraying in an orchard, aren't they?
Right. So have you seen the ads on television about if you're suffering from something or other and you've used paraquat?
Yeah.
Have you noticed in the background? That's the sprayer they're using. Have you ever sprayed paraquat with that? And if you did, you probably do have a problem.
Yeah.
So anyway, I digress, but I saw that going through. But again, we have come a long way. Machines much bigger, more capable today than ever before. How many of you in here run your own rig versus have the dealer run it, your own rig? So several, half maybe, more than half. So again, we a lot of great equipment out there, always making kind of leaps and bounds in that aspect of application. Why do we spray? That's what y'all been talking about this afternoon, is to control weeds. Obviously what we want to do is catch them when they're that size or smaller, so that we don't get to this point, because this is when we have a problem. Although it may be when we use the electric thing. Hey, it's an option, but yeah, we do not want to see them that big. So what we want to figure out is how can we better spray. So we want to help with, I don't think this pointer works. So we want to look at pesticide efficacy. And of course, another very important thing we're dealing with these days is spray drift management. Our goal is perfect weed control. Probably, hopefully that's attainable at some point. That picture was taken a long time ago, and it's back when Roundup was basically 100% on everything, and we were able to get excellent control with no spray drift. So again, what we're going to focus on is the equipment and application, and sort of what we can do to optimize that part of it. So I'm gonna put a shameless plug in for a University of Nebraska publication. This is our version of the Kansas State book that you have in front of you. You can just search online for EC 130. You can get it in a book, or you can download it on like an iPad or something. The reason I mention that is we have some additional information in our book about nozzle selection that, as far as I know, really doesn't exist in a state guide. For those of you who've been around a while, Bob Klein is a person in North Platte. I believe he started with extension in the early 60s. So he's been at it a while. And he has developed a wonderful section in here on nozzle selection. And we'll look at some examples of that in just a bit. Other reference materials you could probably need to have is some of these nozzle catalogs. There's a lot of good charts, how-to guides on what nozzles to select. What's the letter of the law when it comes to herbicide application? The label. So always refer back to the label when there's any question on do I or don't I. But sometimes the labels give you kind of enough information to get into trouble, but maybe not help you get, like, especially for like nozzle selection. But again, always refer back to the label. And then of course, manufacturers' websites. So this is kind of a new thing in the industry, where a lot of companies are going to these websites where they can publish information that's basically up to date to that day. So if you'll notice, these are all dicamba. So Ingenia, Tavium, Extendamax. So they are, they're always trying to get more tank mixes labeled, more adjuvants labeled, and more nozzles labeled. So instead of publishing a hard label every time they do that, they simply go to these websites and publish on there. And actually, if you've been to the dicamba training, this is something that you're supposed to do before you spray, is go to these sites and make sure what you're using is approved. So this is a part of the guide that I referred to. It has a specific page number, that doesn't really matter. It's just a guideline. This is the industry standard for droplet size classification. We really want to look at spray quality, so that's the in general droplet size from extremely fine down to extremely coarse. Industry has had a standard across all companies where there's a color associated with the delivery rate. And so a red is gonna be the same delivery rate in brand X as it is in brand Y. And then we're gonna look at size of droplets. So again, just as an example, up to 25 microns is the size of a needle point, all the way up to a pencil lead, which is about 2,000 microns. So that gives you some kind of gauge as to what we're talking about. This is actually in the guide as well. And this is just a close-up of that same table, and just pointing out that most of our herbicide applications require at least a medium spray droplet size up to extremely coarse. Another thing to remember is when you change droplet size, if you go from a 400 micron droplet to 200 micron droplet, you're getting actually 8x the number of droplets, which means what? If you're going to a smaller droplet size, what gets better? Coverage. What gets worse? Drift. So it's a trade-off, right? So some are gonna work better with a little bit bigger droplet size. Others we're probably gonna have to go with a smaller droplet size and have to mitigate drift some other way.
Does your gallons per acre affect that? How does that play in there, or does that play in there at all?
Yes. Yeah, and actually Jeff will go through some really good examples on that, so I'm gonna leave that for him. But, you know, pressure, gallonage, speed, that all can affect droplet size and certainly can affect coverage. So this is just what we were talking about as coverage maybe goes down due to droplet size, drift risk goes down as well when droplet size gets bigger. If you're looking to penetrate down into the canopy, what we found is that actually logically you would think if you kind of fog it in there you get better penetration. That's not the case. If you're trying to get down into the bottom of the canopy for weeds on the floor, on the ground, or certainly if you're trying to spray like a disease and you're trying to get that through the canopy, you're better off using a larger droplet size. So this is a current label for Acuron. So if you're getting ready to spray, you're gonna have the label, right? You're gonna be sitting there right before reading it. And you're gonna see, well, for pre-emerge applications, this is telling me I need to have a spray volume of 10 to 80 gallons. That's a pretty big range. So again, they give you some information, but they leave it up to you to make some detailed decisions. If you're going post, it's a little bit smaller, 10 to 30 gallons. On the next page, it says use only nozzles producing medium to ultra coarse droplets. Do not use nozzles producing fine droplets. So that's pretty direct. So what nozzle do you use?
There's still a lot of nozzles.
Yeah, there's still a lot of unknowns, right? So, again, this is in our book. There's, I believe, 5 or 6 pages that summarize that information that I just gave you for every label out there. And then you take that information, I'm gonna skip ahead. You take that information and you go to this part of the book, which tells you specifically which nozzles you can use to give you that droplet size. So if you look at the top, it says recommended sprayer nozzle tips to achieve various droplet sizes for medium spray quality at 10 gallons per acre. And again, there's a chart in there for a lot of different gallons per acre, medium, coarse, ultra coarse. Within the chart, you're gonna have your nozzle spacing. You're gonna have what rate you're gonna spray per acre. And it's gonna give you even the specific nozzle at a given pressure to use to attain that type of droplet size. A lot of information.
Oh my God. How long do you think you can do all this?
60 years.
So he's right, you know, what we learn is always built on what we already know, and over time, the jump is big, but the increments are small.
And what we're trying to do is summarize it so that you guys don't have to do all the legwork to get to this point,
Well, or guess.
or guess. And so I skipped over this part. So this is actually a chart out of the TJET nozzle catalog. So it's going to give you some of the similar information. And frankly, this is where a lot of our chart was developed, using all the various companies' charts. Again, trying to summarize it to give you maybe a little bit easier piece of information to use.
All right, that's it for you?
I'm done.
All right. Thanks, Randy. So I heard Randy mention Bob Klein. I don't know if that name's familiar down in this part of the world, but I've worked for Bob for like 15 years, so I got a good introduction to all the pieces that go into spray application, and that developed out of the EcoFallow development of that program in the late 70s and early 80s, where if you didn't get 100% control on fallow, it sure showed up. So that's what got Bob's interest into application and how we can make it better, and why we're located where we are in North Platte, and because that's where he was and not on the main campus in Lincoln. All right, so as Randy mentioned, there's a few things that go into an application, and the equipment is an important part of it, on top of the pieces that Sarah and Tyler talked about. What you're going to use, how you're going to apply it is important as well. As you can see on the screen there's just a few things to consider when you're deciding how you're going to apply a product. And we'll touch on a few of those as we go forward here. Okay, those of you that have your own sprayers, how many nozzles sets do you have? How many different nozzles? 5? Okay. So good, because the point is getting out there that there's no one nozzle that you can use for all applications. There's been many of them developed to be tailored for specific products or scenarios, and like Randy said, we're trying to get the products their best shot to work. So choosing a nozzle that is appropriate for what you're applying is an important piece of the puzzle. Other factors as well as nozzle type, if you're doing broadcast or banded, the type of chemical you're applying, herbicide, fungicide, insecticide. If you're using fertilizer as a carrier, that changes things for you a little bit too. Mode of action was touched on earlier. That's important on how you're going to apply something. Managing risk of a drift off target. Some of the other pieces, the rate, pressure, travel speed you're going to go, and of course your target, the crop, or the pest you're targeting, are all pieces that go into the decisions you make on how you're going to apply it. So we talked a little bit about nozzles. How often do you change them, or what triggers you to maybe replace some nozzles?
Check them with a meter, see if they're still in spray.
Okay. Or if you run the sprayer enough, you turn around and look back, you kind of get an idea what's normal, and if something is looking goofy, it's another way to, but you're exactly right, as the animation's skipping off of there, but calibrating is a good way to check, see if a nozzle's still there. Usually if it's within 5% of what it's rated for, it's still good. And typically if it's putting out too much, it's mean it's worn out and the rate's not right, and also the pattern formation is probably not good as well. So Randy's talked about things have changed over the years. We used to use brass and steel nozzles. Those really aren't used much at all anymore. The more common used today have air inclusion or AI nozzles to increase droplet size. And also there are several twin fan or dual fan type nozzles as well that are air inducted. That top one in the middle is AI 3070 from TJet. It's specifically designed for head diseases in wheat. It's got two pretty sharp angles, so it's getting all of what you're spraying to intersect in the head, which is where the product needs to be to work. So a lot of nozzles are being tailored to specific applications. So we talked about this a little bit earlier, the color coding system that's there. So if you grab a brown nozzle from TJet, it's going to be the same flow rate as a brown nozzle from Hypro or Greenleaf or Wilger or whatever brand or type of nozzle you're working with. And those are flow rated at 40 psi. So that red nozzle will give you 0.4 gallons per minute at 40 psi. As we mentioned, that's a good way to check calibration, but also if the nozzle's still in spec and good to be used. So all those nozzles on there are red, so meaning they're putting out 0.4 gallon per minute. But what's the difference between them? I mean, why would you choose the one on the left versus one of them on the right, or you'd go with the one in the middle?
Well, it depends on your conditions. Like the TTIs, you know, they are supposed to have less drift.
Choose that one, right?
Yeah. Less drift than like the XRs and
Which is the one clear on the left. Exactly right. It's the droplet size. Those all divide that liquid flow into different size pieces, and depending on what you're trying to treat or in what product you're using, you choose a different nozzle to achieve that. So this is a spray boom with some lights behind it over a patternator. A patternator is a fancy word, that machine that can basically see how consistent across the spray boom a particular setup is. But it has all the different types of nozzles on there, and you can visually see the differences in the pattern and the drop size that's in there. So we happen to have a patternator there in North Platte to look at different application scenarios, boom height, nozzle spacing, nozzle, spray pressure, and of course spray solution. All of those are factors in how consistent across the boom is. So we can look at that and not just eyeball it, but get hard numbers from it. And we talked a little bit about plug nozzles. You can see that one there. We intentionally plugged, one of the students did, just to see what the numbers would look like coming out of it. The graph here on the left is showing 4 different boom heights, and then how consistent it is across the boom. So the one that jumps out a bit is which one? Which color jumps out at you? The blue one, right, because it's going up and down. It's not consistent at all. And when you get out to where that plug nozzle is, you can really see how it impacted consistency across the boom. I'm guessing nobody really runs a boom too low. Is that a fair statement? So this scenario, it being that extreme, probably isn't going to happen very often. But if it did, what's going to happen in that dip where it's really low on the blue? What's happening there?
skipping.
If your kind of average is up there at 4 fluid ounces and you're down there at a half a fluid ounce, you're getting a fraction of the rate applied there, right? If you happen to have weeds or your pest in that area, what is a good way to develop resistance?
Not get them killed.
Low rates, exactly. And then what about the peaks?
Too much.
If you're applying, yep, and it's something that could injure the crop. You could be injuring the crop in those areas. So we found that typically if you get up to 24, 30-inch boom height, that gets things pretty even on 20-inch nozzle spacing. So it's a good boom height to run at. All right, some of this has been covered this afternoon in some of the other talks on, basically on weeds it's been focusing on, but what are we targeting? Insects are pretty common in some parts of the world. We've had a lot of students from Brazil in our group, and growing up in Nebraska where you grow one crop a year, thinking that, hey, you can grow 3 crops a year because it never freezes, that's fantastic. But also, winter is a good insecticide and a good fungicide because those things don't survive that. So they have constant problems of having to treat for insects that could be at any growth stage the entire year and fungal diseases all year. So they're much bigger problems fighting insects and fungal diseases there. Weeds for us here in the Midwest is definitely the biggest problem. And some of the talks earlier today addressed this as well. Are you trying to treat to prevent them coming up to pre-emerge or treat them later on? Those things all play into our decisions on how we're going to apply a certain product after we've decided what product to use. So after you've identified what you're going to use and what you're going to target, what are some of the major things that may influence how you decide to apply that product? We've been touching on a few of them. Gallons per acre, carrier volume. Of course, that's a huge one. If there's language on the label regarding droplet size you've got to use, such as Randy mentioned, the dicamba and the Enlist labels have that. If not, still selecting a nozzle is important, and your drift, managing drift if it's a concern for you.
Surfactant would be in there?
Surfactant, yeah, if you want to add any adjuvants to the spray solution to enhance the active ingredients, how well it works, or putting a drift retardant or drift reducing adjuvant in there to help with drift mitigation.
What about water quality?
Water quality, yeah, that's another one for a lot of products, glyphosate especially.
Like what is it?
Glyphosate, Roundup.
So that's where the AMS comes in for
Yep.
hard water?
Yep, for sure.
Which condition your water first?
There are other ones other than AMS, because as we know now with dicamba, it's not good to be putting AMS with it. It's known that AMS will reduce the pH, and that basically takes away the advantages of the modern molecules. Basically takes them back to Banville as far as a volatility concern is. That's why AMS is not allowed with dicambas, with the ones you can spray in crop in soybeans and cotton. All right, we'll move to managing the application itself, deciding on volume, nozzle, and any adjuvants. So this is taken out of the T-Jet spray book for the AIXR nozzle, which produces mid-range to coarser droplet size. But if you look in there, if you're targeting 15 gallons per acre, there are several places where 14.9 comes out if you are looking at 20-inch nozzle spacing and the speed you want to go. But one thing to note in there is each one of those comes back to a specific drop size they have in here. So that one would be a coarse, very coarse, and then extremely coarse. And like Randy mentioned in the standard for those represent kind of broad categories, but still can help you make decisions on meeting some of the recommendations that are on the labels. And of course, we know the larger the drop size, the less the drift risk. We talked about the orifice size can impact the spray droplet size. The pressure does as well. You increase spray pressure, typically your drop size goes down. This is a study one of our grad students a few years ago did, Cody Creech, looking at 5, 7.5, 10, 15, and 20 gallons per acre spray volume with 4 different active ingredients, 2,4-D, lactofen, which is Cobra, glufosinate, which is Liberty, and then a glyphosate. And one place we saw some differences was with Cobra and glufosinate on velvet leaf and amaranth. What's one thing those 2 products have in common?
Run that by again.
Cobra and Liberty, what do they have in common?
Contacts.
Exactly, they're contact herbicides. Although we're learning more about Liberty, it's been labeled as kind of a localized systemic. It'll work within the leaf that it hits, but it won't translocate throughout the plant. But still, it has a lot of contact properties. And you can see there, the letters above the bars mean in the statistical world that those are different. You can see those, the higher gallon per acre applied gave you better control. So 2,4-D and glyphosate, what are those? What category are those products? Are those active ingredients?
They're contact too.
They're systemic, exactly. They're translocated throughout the plant. And what we found pretty much in general, carrier volume is not much of a driver at all in how well those products work. So systemics, carrier volume, not a big deal. Contacts, definitely a higher, a higher carrier volume helps those work. And how does the larger carrier volume help it?
Get better coverage.
Coverage, exactly. Randy mentioned before with that one slide, how you can take that 1 drop, cut it in half, you get 8 more, and cut it in half again, you get another 8. That's one way to get coverage, use smaller drops. Another way, we could just put more big drops out there by using a higher carrier volume. And that's what these 3 cards illustrate. So we have a large spray chamber there that has 3 nozzles on it, and the boom will travel 18 miles an hour. So we can replicate what you guys are doing out in the field. Usually spray chambers are just a single nozzle and they'll go 4.8 miles an hour. So not very indicative of what you guys are doing out in the field. So we could do multiple nozzles and run the speeds you guys are out in the field. And that's what we did here. These are just 8.5 by 11 sheets of photo paper. And we'll put a blue food grade dye in with a spray solution and spray over. And we can scan these in a computer and then have a program analyze them for coverage, which we've been talking about. It's important for especially contact products. So the one on the left is at 10 gallon per acre, the one in the middle is 15, one on the right is 20. And the only difference between the 3 to get those gallon per acre is speed. It's the same pressure, same spray solution, same nozzle spacing, same boom height, just speed. So I've heard Greg Kruger was my previous supervisor and the head of our lab, and he said if the higher carrier volumes help cover up some of the other challenges of an application. Some other things can be more difficult, but if you do a higher carrier volume, it will help mitigate some of those other things that can make a challenge to an application being successful.
You know, sir, if you do the math, and you take 20 gallons an acre, 43,560 square feet an acre, and figure out how much volume of material is going on a square foot, it's pretty darn small.
Mm-hmm.
It's almost shockingly small.
Mm-hmm. we're really trying to apply a very thin film, or even at 20 gallon, there's still a lot of white space on that card. That's exactly right. So Randy touched on canopy penetration a little earlier. Some of you in here probably remember, 15, 18 years ago, Asian soybean rust was going to move in, and that'd be a huge challenge in soybean production. Never materialized, but we did do some work at that time looking at what nozzle setups, what droplet size would be ideal for getting down to the lower leaves if you need to, if a disease or an insect is present down on the bottom part of a crop. And we'll do this by putting smaller pieces of that photo paper down in, put a dye in the solution, and then evaluate what's getting down toward the bottom. Because we talked about some of the reasons to get down to the bottom of a canopy. Another is, talked a little bit earlier today already about some late emerging weeds that you may try to target and be a little more of a challenge, especially if you're using 7.5 or 15-inch spacing on planting soybeans. Those will canopy a little bit sooner, be a little more of a challenge to get some of those late emerging weeds. One of the studies we did, I'll try to explain it here. I know there's a lot going on this slide, but concentrate on the white or yellowish that are at the bottom of the bars. Those are the cards that were placed in the lower leaves. And in general, as you work from left to right across the chart, droplet size is getting larger. The nozzles we use to produce the larger droplet size spectrum. So as Randy mentioned, it's common thought that you need to blow in small drops to get down into a canopy, but we have found larger drops applied as vertical as you can are actually the best way to get as much of the spray volume down into the bottom. And it makes a little sense, larger spray drops will have more momentum and be able to carry through anything that might get in the way. And to getting down into the bottom of the canopy, if you're going at an angle, you're actually going through more canopy to get there than if you just came straight vertically down. That's what we're thinking, the reasons why the larger drops and as vertical as you can get it to get to the bottom of the canopy.
So would your speed of application influence that?
Speed it could, yeah.
Because it would seem like the faster you go, the more that the droplets would be coming down more at an angle.
Right. And some of the nozzles, the turbo T-jet nozzles, or TTI actually, are angled back a little bit. All right, so next, we know what product we're going to use, an application type. We talked about this already, what product we're using, how are we going to apply it, is it a contact or systemic? So that's some of the things that we're getting to making the final decision how we're going to apply a product to get it to work to its best. So Randy shared some of this earlier too on the label is a good source of how a particular product will work the best. Lotus is what? What type of? It's a systemic product, and some of the parameters that are on the label kind of indicate that. Do not use fine or extra coarse drops, so it's saying don't get too large, there's a limit to that. Use a minimum of 10 gallon per acre, so they're covering that a little bit. And one statement on there that's a little different, the AI nozzle should be used at or near 80 psi. And if you've ever used the AI nozzle, its top end is 90 psi. So we're not sure why it's saying to use it at its maximum pressure. Not sure why that's in there, but. Sharpen. Is that used this part of the world? What type of product is it? It's a PPO, so it's a contact type. So It might have a little different language on there, and as far as its application instructions, they're telling you most effective way to reduce drift potential is to apply the largest droplets that provide sufficient coverage and control. Which is true, right?
Yes.
But how do you achieve that in a more detailed manner where you know which GPA to use and what nozzle to use? They do talk about using high flow rate nozzles to apply the highest practical spray volume, and nozzles with higher rated flows produce larger droplets. That's true too. If you do an O2 nozzle versus an O6, that O6 will typically give you a larger droplet size category. They also mention for information on the nozzles, go to the nozzle manufacturer and work within the parameters that they suggest. So like Randy said, this is one reason that Bob worked on getting a section in our weed management guide to help understand what's going on with some of the language on these labels. Excuse me, they do mention medium to coarse spray droplets, and watch the wind, 10 mile an hour or less, because if you're using smaller droplet categories, your risk of off-target movement due to wind goes up. And it actually has a 50-foot buffer or setback on the downwind edge to susceptible species. So some of these labels do have buffer zones in them. And of course those are with the enlist and dicamba labels as well, so it's where things are going in general, it seems, as new labels come out. In the EC 130 guide, there is several pages in there on working your way through nozzle selection. And Randy's already mentioned some of the sections in there when you work to find your product. A lot of them are listed on that first page, looking at the labels for that product and pulling some of that information out, so it's in a more of a compact guide for you to find that a little more conveniently than reading through an entire label. For that information was pulled from the labels, but it's always a good idea once you've got it to go and see what the label says in addition to the information that's been pulled out. And then from there, like Randy went through, what nozzle types can help you achieve the desired spray classification and the carrier volume that you're looking for, with the speed that you would like to go as well. But on there, you always check the label before applying. You've heard that a few times today. So we talked about how to make the product work its best, product efficacy, and the other concern. I usually ask one of the first questions, if you're in the cab, what are a couple of the things you're most concerned about? And you guys had already talked about that, getting the product to work the best, and then drift mitigation. So, of course, with the dicamba in crop, in soybean, and in cotton products, in the enlist, there's some enhanced measures to mitigate drift risk on those. So in general, off-target movement can take three forms. There's physical drift, the drops actually blowing off the spray rig during application. Sprayer contamination, if there's something left over from a previous load. You're moving to a different crop or changing traits within a crop. Some of that can be left in there and taken to another field where you don't want it. And of course with the auxins or the growth regulators, they do have some propensity to volatilize, so managing that as well is a concern. Once again, in the guide, there's some information on reducing drift. So for the bigger factors that influence herbicide, or not just herbicide, but any application drift, surrounding vegetation or what's downwind from you is a big concern. That's the buffer zones on a lot of labels. Wind speed, of course, higher wind is going to make you more prone to moving off target. Boom height, we mentioned before, going too low is not good for the quality of the application, but of course going too high, it opens up the door for off-target movement. You got a longer distance down to your target, so more of a chance for wind to move it. And then of course droplet size we talked about a bit as well. Big factor in influencing drift. And the newer labels are, like we've mentioned, are including what nozzles have passed their test, and then also with this enlist example, buffer zones that are required. So some of those things are included on the label for products. Surrounding vegetation important. So I don't know all the facts on this, but it looks like the beans closest to the corn there look pretty good, and then the other ones over to the right are a common scene the last few years, right? So I don't know why, if they thought, having a buffer of dicamba beans when they're spraying dicamba in corn was there, or if it was just planting seed or what, but you can definitely see the impact of the dicamba moving off, assuming the dicamba was sprayed on corn, because I don't know the exact particulars on it, but that's just what it may have happened there. So one of our students did a study in our wind tunnel that we have. We've got one, there it is, picture of it. We call our low speed 4 foot by 4 foot diameter on it, and it's 48 feet long from the front end where there's a fan blowing in, and then on the bottom end is another fan that's pulling air out. So we can have a pretty neutral pressure inside. The wind's just moving along and not being necessarily pushed in from the front one or pulled from the back one. They're pretty evened out. That big silver box there is a scrubber. So we've actually cleaned out the air that's had anything exposed inside the wind tunnel. So one of the few places in America and in the world that can work with active ingredients indoors like that and look at studies like this. So what he did is we looked at two different nozzle types, a TP nozzle and an AI nozzle. He chose the TP because he's just doing a single nozzle in the wind tunnel, and he wanted to use an even one that had across the nozzle plume an even deposition. Those are the type you would use behind the planter if you wanted to band a herbicide behind the planter and not broadcast across the whole field. So the TP nozzle produces a droplet size spectrum similar to or just a little bit smaller than an XR. And that AI, of course, is an air inducted, so it produces a much larger droplet size. And you put collectors out downwind to quantify how much drift is happening at downwind. And you can see from the chart on the left that the AI nozzle came down closer to zero much quicker than the TP nozzle, which you expect with the droplet size distribution that those nozzles produce. He also calculated how far downwind would 1% drift be detected, or 1% of what you were spraying. And the TP nozzle, that's about what, 17 meters, which is 55 feet, was 1%. And the AI nozzle was about 5 meters or 15 feet. So it's just showing again the influence of what nozzle you choose on the risk for off-target movement. You can see from the water-sensitive cards underneath how the drops actually deposited at the distances downwind. So we've talked about droplet size a lot here. And we're not just pulling numbers out of thin air, we're actually measuring them on a laser diffraction system in our group. We can look at different nozzles, spray pressure, spray solutions. All of those play a role in what is actually coming out of the nozzle. And we can measure that with the laser diffraction system. So we've talked about nozzles, spray solutions. Now how do they interact? We did a study looking at Roundup Weather Max. This was years ago. So Weather Max was the Roundup, the new one at that time. And then several different DRAs or drift reducing adjuvants that could go in there. And there are several different categories of DRAs as well. One of them we looked at, the purple one, was a polymer. The light green one is a microemulsion, and the blue one is an invert emulsion. Now, anytime you hear emulsion, what do you think?
Well, emulsion is something that's not mixed in, it's suspended when it's not actually dissolved.
And what does not mix with water very well? Oil, exactly. So it's an oil formulation. That's exactly right. And the light yellow is just water alone, and just Roundup Weather Max alone is the orange. So we ran those through 5 different nozzle types. The bars represent the volume median diameter, or the average drop size in the spray plume. And the smaller bars on the bottom are the percent less than 105 microns, or a measure of what is considered driftable. When you look at the XR nozzle, adding the Roundup into it definitely decreased the average drop size, and it increased the fines from 11 to 17%. But if you put any of the DRAs in there, it brought it up to at least to the level of water alone. So any of the DRAs worked with the XR nozzle. If you look at the TT and the TF, the turbo flood, what do you notice there with the different DRAs? The bars are lower, right? I thought those are DRAs. But the average size is smaller, and the driftable fines went up just a little bit. So we have learned that nozzles that have a turbulence chamber, like the TT and the TF, anything that's an oil that goes through there, actually creates a smaller droplet size spectrum than not using the DRA.
Well, I think your circulation breaks them down too.
Exactly, that turbulent chamber breaks those emulsions apart, and when it exits the nozzle, it's actually giving you a smaller droplet size spectrum. Both of those nozzles behave that way. But you can see the polymer type were better than water alone. Look at the air inducted types, the AI and the AIXR. And what do you see? Those oil types performed very well with those. So, I know not everybody has a laser diffraction system to measure things like this. So, one thing that we've suggested, if you're trying something new, definitely look out the back, and you'll have a good idea if you're seeing small fines coming off, and especially if you got some experience working with other things with that particular nozzle to get an idea if something is working or not. But in general, oils, not just adjuvants, but actives as well, like the clethodims or Cobra and those, with the turbulence chamber nozzle, they typically don't get along that well. Here's another study we did along those lines of with a particular nozzle and spraying 21 different spray solutions through it. And the TJET classification for this one with water was medium. So those bars represent where medium range is for our system. And you can see there's a couple of products that decreased less than medium, and several of them increased quite a bit. So it's just showing again the impact of, it's not just the nozzle, it's what going through the nozzle can impact what it is. And this was a TT nozzle, so likely those two that are less were oils that resulted in that smaller droplet size, the smaller VMD. So some of the messages out of this, we know particle drift can be influenced by formulation. We just saw that in the last couple slides. Nozzle selection has the greatest influence on particle size in conjunction with some other things, but the nozzle type itself is a big factor. Adjuvants can reduce drift potential. We saw that, or increase droplet size, but must be tested or consider, the oils with the turbulence chamber. The next point, is definitely true. Common sense should rule the day. If the wind's blowing a lot, of course, the droplets are going to move. Pay attention to what's around the field. And drift will happen, but minimizing its potential is the goal. And of course, we mentioned several resources today. The weed guides, weed management guides are excellent sources. The nozzle manufacturer books are good sources as well. And of course, the biggest one is the herbicide or product label, what information it has to help it work the best, but also mitigate drift. So just a couple other things on labels. Randy mentioned live labels. They're kind of a thing for some products where you got to go online and see what the latest info is. And when the Enlist products were relabeled here in January, kind of a shock for Nebraska. This big chunk of the central part of the state is not labeled for any Enlist applications. Same is true down here in Oklahoma and southeastern Kansas. And those are tied to the burying beetle and concerns over impact on that threatened species. What we understand is some data has been submitted, and they just ran out of time for when the label expired back in January to get a new one out, and they just haven't gotten through the data approval for these areas. So doesn't look like this year we'll be able to use them, but hopefully the data in the future supports not impacting the threatened species, and those will become available again. That's what we understand. But some of the labels, and Enlist especially, has a lot of application requirements. Of course, dicamba, if you've worked with that the last few years, a lot of stipulations to apply it. Anybody here work with pulse width modulation? A couple? So here's some videos that one of our students put together, kind of showing how it works. It works by having the nozzle valve open a certain percentage of the time. The one on the left is only open 20% of the time, 40, 60, 80, and 100%. And it's kind of neat how he set them up. They all open at pretty much the same time, but you can see that how long they're open impacts the flow rate coming out of them. Because that's basically what it's doing. It's regulating the flow rate without changing the droplet size. So most sprayers have a rate controller in them, right? And as you speed up and slow down, it's providing more or less flow, so it keeps the carrier volume or the gallons per acre the same. And we know increasing spray pressure changes spray droplet size. If you go faster and increase that spray pressure, it typically decreases drop size, and that increases your drift potential. So what the pulse width system does is changes that flow rate through changing the percentage open time, and that has very little impact on spray droplet size. So you can change speed and not impact the spray droplet size is the huge advantage of the pulsing system.
Is that a relatively new deal?
So the patents, I believe, came out from an engineer in California in early to mid 90s.
So it's off patent?
It's been around for a while, and there are several systems available now. Capstan had one of the first ones, but John Deere has their system. TJet has a system. There's several alternatives. I don't know if it's off patent per se, but
My understanding is that most patents in the United States, but not all, are typically 17 years.
17 years, okay. So one advantage of it with that electrically controlled valve is that nozzle can be controlled individually. And if you're making turns in a field with the sprayer going, of course the inside is going at a slower speed than the outside. So this diagram from, I think this is a European version of a PWM system, shows that outside could be applying 9.4 gallon per acre while you're targeting 18. And the inside, of course, is going much slower, so it's applying a much higher rate. Pulsing system can basically take those swings of the outsides of the boom into account and basically get the carrier volume the same across the boom and account for the different speeds of the different parts of the boom. So you don't end up with over application or under based on where if you're out at the ends of the boom. Another advantage of the turn compensation part of the pulsing system. You can't put just any nozzle with them. Any of them that are nozzles that are Venturi or air inducted do not work the best with them. Basically, with that air induction port, any solution that is in the nozzle while the valve is shut is just going to fall out and not be pressurized and form a fan. It's just going to fall in a larger drop right under the nozzle. And that product is not being optimized or being spread like you would want. The non-Venturi types or non-air inducted do not have those air induction ports, so there's basically a vacuum that develops in there that holds that solution in and doesn't allow it to fall out. So non-Venturi type nozzles or non-air inducted are the ones to use with the pulsing systems. Tommy Butts was a PhD student in our group a couple years ago and did a lot of work with them. Optimal duty cycle is between 40 and 100% with them, and stay between 80 and 100 basically. Like they recommend your normal speed to be at 75 to 80%, so you got some leeway either way to go slower or faster. If you get the pulsing too slow, the consistency across the boom starts to degrade a bit. So you want to keep the pulsing up to at least 40%. So some emerging technology. Randy had this picture in earlier. Do you know what that is?
Laser?
Laser, yeah. So there are systems out there that can basically detect green from brown. So in a foul situation, it would only spray where it detects green. There are systems in development to discern weeds from crop. So you could use a system like that in crop. What's an advantage of that? All right, cost. That's what they're targeting, to try to reduce cost. Europe is actually quite a bit ahead on these systems because they have mandates to reduce pesticide use. And that's one way they're trying to do it is through systems like this, through technology to only treat where the pest is. In our case, weeds, only treat where the machine sees them. So that's some new technology that's coming down the line. So thanks for having us today. Any questions or comments?
Have you tested in your wind tunnel, different companies have nozzles that are, put two nozzles on at an angle, or maybe the turbo has it already going out at two different angles? Have you tested any of those, and what does that compare to one that just spray straight down? And then at that speed you're running, does it matter which direction the nozzle's pointing at that speed for best coverage?
So I believe the nozzle manufacturers like Greenleaf make several of those twin fan nozzles. And yes, we have tested them for drop size. They're air inducted, so they do produce a pretty large droplet size. And the manufacturer will typically recommend to alternate on the boom forward or back, depending on if the fans are oriented differently, to try to keep them from intersecting with themselves too much.
And what does that show on does it change your coverage any in that tunnel? By not having the fans hitting each other as they're interfering?
So on the patternator, I don't know if the students have done much with twin fans on there, or we haven't done much with the twin fans on there. Mainly just the single fan nozzles on the patternator so far. In the wind tunnel, that's mainly just used for measuring drop size. So whatever's coming out of the nozzle is what we're measuring. So sorry I can't answer your question too detailed on that, other than like 3D nozzle that High Pro has. that Syngenta's worked with that's kind of angled in one direction. I know they suggest forward, back on the boom to not have them intersect with themselves too much. Most nozzles, the caps, if you look, they're turned just a little bit, so one's actually spraying behind the other to get the overlap. Yes?
Right at the start of your presentation, whether it was yours or the other gentleman, you mentioned an EC 130. Can you go back to that, cause there was some information there, I kinda wanted to share that with somebody else after, it was passed, and I thought, I should've wrote that down, I wrote down the EC 130, and then,
That's just a reference to the book.
Yeah.
yeah.
So that's the weed guide, the
Yeah,
Nebraska
but-
version.
But it would be, I kinda wanna get the, go online.
So you can't download the book, correct?
Well,
You have to
actually, you
buy
can.
it. But you have to buy it first.
Yeah, I think it's $10 for a digital copy. You can get a spiral bound copy for 18.
Where from?
If you'll go to that website, if you'll just.
Or just
search
Google
EC
130 UNL or
It'll
something
pop up.
like that, you'll find it.
EC
So that's all you
130.
gotta do is EC 130, good
Yep.
one?
And it'll show up right when you Google it.
Or Nebraska EC
Yeah, you might put
130.
Nebraska in there somewhere. And I would offer guys too, if you're ever up around North Platte, if your motorcycle gang is going up to Sturgis, swing in, we would love to, give you a quick tour. And, I think the coffee's always on, so, stop by.
So just like Nebraska EC 130, Google this.
Yes, sir.
And it don't have to be anything on the spray application or.
Nope, it will just pop up and then you can click on that and it'll take you to the website.
And then can you get any information off of that without buying, or you need to, how's that work?
I think you need to download
I-
at least get the digital copy.
I think some previous years are on there,
Yeah.
free of charge, the current year. They pay. So it's interesting, going back to Bob Klein, some of the Weed Science Society of America, I think he gave a talk once on the progression of Nebraska's weed guide from its inception in the early to mid '60s to now. And it was like 6 pages, the original one, and now it's up to 300 and some.
But it's weeds, insects, and diseases, so it's a combination of all
Okay,
of
and
this.
Kansas is just weeds,
Right.
this particular one.
Right.
Yeah.
And there's a lot of great information in that one too, we were reading it on the way over. And so the combination of those two, I'll give you a pretty good sized picture.
Well, let's thank these guys for coming down.